Okay, picture this, a quiet, historic city in the heart of Belgium called Leuven. From the outside, you'd think it's just another beautiful European town. But inside one of its buildings, the future of pretty much every piece of technology we use is being mapped out. So what is going on in this, unassuming city?
Yeah, it's a really good question, right? How can just one lab in one town basically call the shots for corporate giants like Intel, Samsung, and TSMC? Well, the answer, and this is wild, is all about mastering the art of drawing with invisible lines of light.
So yeah, welcome to Leuven. While tourists are busy admiring all the Gothic architecture, the world's most advanced engineers are looking at a completely different kind of blueprint. The blueprints for the next generation of microchips.
To really get what's happening here, you've got to think of a microchip like a tiny, bustling city. It's got roads for electrons, bridges for data, and power lines made of metal layers that are just atoms thick. And this entire metropolis, smaller than a grain of sand, the whole thing is basically drawn into existence with a pen you can't even see.
In that pen, it's literally made of light. The art of using it is called lithography, and honestly, it's the single most important process in all of modern technology. It's how we build these microscopic cities. Okay, so here's the key thing. The finer the pen you're drawing with, the more detailed your city can be, right? A finer pen means you can draw smaller roads, tinier buildings, and pack a whole lot more power into the exact same tiny space. For decades, the entire industry has been on this quest for an ever finer pen. And this is where we see this just incredible leap in technology. For years, the industry standard was a thing called DUV, which used light with a wavelength of 193 nanometers. But the new frontier, extreme ultraviolet, or EUV, shrinks that all the way down to just 13.5 nanometers. So what does that mean? It means our pen is now almost 15 times finer. I mean, this isn't just a small step up. It is a full-blown revolution. It's the invisible breakthrough that lets us jump from one generation of chips to the next, making all our devices faster, smarter, and way more efficient. And who's at the very center of mastering this whole revolution? Yep, that lab in Leuven, IMEC. But here's the twist. IMEC doesn't actually sell any chips. Their product is something way more valuable. There's this great way to think about IMEC's role. They don't build the car, they design the perfect assembly line. They're not making the final chips that you go out and buy. No, what they do is perfect the process. They write the ultimate recipe book, the exact temperatures, the right chemicals, the precise timings needed to build the most advanced chips on the planet. And when you look at a standard production factory versus IMEC, the difference is, well, it's huge. A fab run by TSMC or Intel, that's all about volume, right? Pumping out millions of identical chips as efficiently as possible. But IMEC's famous pilot line is built for one thing, experimentation. It's like a full-scale factory simulator, a giant sandbox, really, that lets companies test, fail, and innovate so they can de-risk their process before they go and spend billions on a real production line. But here's the catch. Even with a pen that's 15 times finer, we are smashing right into a physical wall. There's only so small you can make things before the laws of physics just say, nope. So, if you can no longer build out, you have to start building up. Okay, so think about it like this. Every single transistor on a chip is like a tiny little faucet controlling the flow of electricity. For decades, we've just been making the faucets smaller and packing them closer together. But now, they're so crammed together that electricity starts to leak between them, and that creates heat and instability, a real mess. The 2D city is getting way too crowded. So what's the solution? Well, the solution, which IMEC is pioneering, is to go 3D. First up, they created nanosheets, which stack the current carrying channels on top of each other. Then came fork sheets, which add these tiny insulating walls to stop the leaks. And the final step? CFETs, which stack the entire transistor. We're not building a flat suburb anymore, we're building a skyscraper moving into the third dimension. Now, you can imagine, pioneering this kind of crazy 3D architecture is, well, it's astronomically expensive. So how does one lab afford it all? And that's where the real genius of IMEC comes in. It's not just the tech, it's the business model. It's built on a pretty radical idea, getting fierce competitors to work together. And this is where it gets really fascinating. Tech's biggest rivals, we're talking Intel, Samsung, TSMC, they all pay IMEC a membership fee.
I know it sounds totally counterintuitive, but the cost of this foundational research is so high, it's just too expensive and risky for any one company to do it alone. So IMEC provides this neutral ground, that shared sandbox where everyone can test out their ideas before betting billions on a new factory. And you know what? This absolutely brilliant model, it works. The trust in IMEC is so high that the EU and its partners are investing 2.5 billion euros for them to build the next pilot line, one that'll perfect the recipes for chips smaller than 2 nanometers. I mean, that is a massive vote of confidence. Okay, I know this all might sound super abstract, right? Nanometers, lithography, pilot lines. But the work being done in this quiet lab has a direct and very real impact on your daily life.
Just think about those amazing, crystal clear photos your phone can take, especially at night. We usually give all the credit to the software, the AI processing. And yeah, that's part of it, but it's not the whole story. The real hero here is the hardware. That clarity is possible because the transistors in your phone's camera sensor are now so perfectly made, thanks to those manufacturing recipes perfected at IMEC, that they leak less electrical current. When you have less of that leakage, you get less digital noise in your photo. It's that simple. That beautiful image is a direct result of a process refined in Leuven. So, you see, the work being done at IMEC really underpins almost every single tech advance we see today. They are literally laying the foundation for the next 5–10 years of innovation. They are the secret architect for the entire industry. But this all leads us to one last, really profound question.
See, we're getting incredibly close to the absolute physical limit, where transistors will be just a handful of atoms wide. The old strategy of just smaller is better is reaching its end. So as the world's technological architect, IMEC's work is now shifting. It's moving from just making things smaller to making them smarter. Smarter in design, in materials, and in that three-dimensional structure. The next great technological leap won't be about shrinking, but about completely rethinking how we build, from the ground up.